The stream I chose to do my case study on is Knapp Creek. I chose to do this stream because I've had the opportunity to both work on it and fish in it, and I wanted to see how its watershed affected the Greenbrier River as a whole. The entirety of Knapp Creek is within Pocahontas County, which is on the eastern part of the state and in the Monongahela National Forest. The headwaters of the stream begin in the town of Frost near Paddy Knob. The stream then meanders for 26.3 miles along private land and Route 92 south to the town of Marlinton, where it empties into the Greenbrier River. Some of the larger tributaries of Knapp Creek include Browns Creek and Dothet Creek. These two streams contribute a large amount of water into Knapp Creek. The stream's channel is formed through a karst geology that includes soluble rocks such as sandstone and limestone. Knapp Creek is in a pretty cool area recreationally. The stream is a cold water fishery, so trout are able to live in it year round. The stream at its warmest comes to about 20 degrees Celsius, and trout are stocked by the Washington Department of Natural Resources in the spring as well as the fall. The stock trout include brook trout, rainbow trout, brown trout. Along with these stock trout, there is native brook trout, as well as some pretty cool cold water species that inhabit the stream, such as the federally endangered candy darter, the Appalachia darter, which is endemic to West Virginia streams above Kanawha Falls, as well as, like I stated before, the brook trout. Along with the trout species and darter species, the Greenbrier River Trail runs right along and actually crosses Knapp Creek. The determination of impaired waters involves comparing in-stream conditions to applicable water quality standards. These West Virginia water quality standards are documented in the Clean Water Act. These consist of 3 different components: designated uses, narrative or numeric water quality criteria, and then an anti-degradation policy. I'll talk about both the designated uses and water quality criteria. In the Greenbrier River watershed, water contact recreation and public water supply, as well as the propagation and maintenance of cold water trout fisheries, are the designated uses that have been impaired based on the water quality criteria for fecal coliform bacteria. The human health criteria that is put in place in order to maintain these watersheds shows that the maximum allowable level of fecal coliform contact for primary contact recreation is and cannot exceed 400 over 100 milliliters and more than 10% of all the samples that are taken during the month by the DEP or other state agency. Knapp Creek was 303 delisted in 2008, and its TMDL is included in the Greenbrier River Report. 303 delisting was due to the amount of fecal coliform that was present in the stream at that time. Section 303D of the Clean Water Act identifies 3 sources of fecal coliform pollution. There's on-site wastewater treatment systems, so private landowners that they have a faulty septic system, or agriculture, livestock agriculture, and then point sources like the Marlinton sewage treatment plant, as well as some others. Along with the presence of fecal coliform, large amounts of sedimentation are present from nearby agriculture and farming. These areas are higher in the watershed, and they contribute a lot of fecal coliform to it. So the TMDL that is available for Knapp Creek is part of the Greenbrier River TMDL. Uh, both point and non-point sources of fecal coliform are present in Knapp Creek. The most prominent point source comes from the Marlington Sewage Treatment Plant. Um, Combined sewer overflows, as well as discharge from the plant, get into the stream, so they're allocated a certain amount of um, pollutant to be discharged. The information that's available for the TMDL includes data sets from many different federal and state agencies, physiographic data such as geology, land use, and stream network data. Those come from the West Virginia Department of Environmental Protection, DEP, and the DNR. Water monitoring data comes from the DEP, NOAA, and the U.S. Geological Survey. And then regulatory data such as water quality standards come from the DEP. The methods that are used to develop the TMDL for Knapp Creek are contained within the Greenbrier River report. They're different both for non-point sources and point sources. The non-point sources, which I talked about earlier, were agriculture and then failing septic tanks from private landowners, and then the point source uh, methodology. Um, these come from facility overflows and then CSOs. In order to calculate the TMDL for on-site wastewater, the watershed is divided into 4 different septic failure zones. These are delineated by geology and the number of homes in each zone that release raw sewage. These are all accounted for. The failure rate of the sewage system of each home is calculated, and that data is used as a model to determine fecal coliform reductions. Calculating the TMDL for agriculture involves categorizing pastures into 4 different runoff types based on the slope, the riparian area, and the soil disturbance. Pastures that were used for livestock and higher levels of fecal coliform than those used for hay. Once pastures were categorized, the density of the livestock and their access to the stream was assessed. This led to the development of fecal coliform reductions. Methods for point source, reducing point source fecal coliform pollution. These are implemented by the DEP, and MPDES permits are created to reduce these levels. Most of the pollution in the stream comes from point sources. So the TMDL recommends a variety of different programs and monitoring work that is aimed to reduce the fecal coliform amounts in the stream. For non-point sources, such as agriculture, runoff, riparian buffers are installed. These are going to slow the runoff after a rain event and prevent a lot of the fecal coliform from entering the stream, along with septic repair for private landowners, and then as well as livestock fencing. Having your livestock not be in the stream or close to the stream is going to prevent a lot of that fecal coliform from entering it. For point source permits, the MPDES permits are implemented. These reduce the amount of wastes put into the stream. So the stream health of Knapp Creek is able to hold a variety of aquatic life, so the water isn't too acidic or alkaline. The real problem is the amount of fecal coliform that's in the stream. This is why the TMDL was created. There's over 34 sample sites on the stream that were conducted by the DEP. Whenever the monitoring was conducted, often these samples exceeded the water quality standards. There was a monitoring site that was as high as 1,600 counts over 100 milliliters. The streams, the tributaries of Knapp Creek that feed into the stream itself are also relatively polluted. On the table on the right is the water quality standards that are put in place for Knapp Creek. They're both for aquatic life and human health. The most present bacteria in this stream is fecal coliform. There are no standards for aquatic life, but for human health, for the public water supply, the amount of bacteria should not exceed 400 colony forming units per milliliter, and for water contact recreation, they should not exceed 400 colony forming units per milliliter. Unfortunately, um, the standards for human health criteria are not met in Knapp Creek. There's a total of 7 MPDES permits that are um, listed for the Knapp Creek watershed, starting at the headwaters and ending near the mouth, as well as permits that are on tributaries of the stream that affect the stream itself. They're general and individual permits. They're for point sources. They're sewage and industrial permits that are on the river that are used to regulate the amount of fecal coliform that goes into the stream. The next slide, I'm going to show the Marlinton Sewage Plant's NPDES permit. What is shown here is the NPDES permits for the Marlinton Sewage Treatment Plant. On the left is the permit for 2012, and on the right is the permit for 2018. The parameters shown are what is being discharged or what is allowed to be discharged from the facility. As you can see, the numbers of the pollutants have gone down significantly for this year in comparison to 2012.